Good morning. Hope y'all's having a good day. Here is an Indramat bus power supply, and it's model TVD 1.3-08-03. And we got this bus power supply off the internet, so we need to test it. But before we do that, we need to take the cover off and make sure that everything inside looks acceptable. Okay, all right. So far we can see that the little plastic cover that covers up the high voltage has been broken. So let's get that out of the way. I see a screw under here's come loose. We'll have to cinch that back down. Okay, there we go. That's out of the way. There's the loose screw. Oh, there it goes. Goes over here. All right. Plastic pieces all over the place. You always want to go inside when you get something off of the internet. We've gotten things off the internet. We go inside to make sure they're okay before we apply power to the unit, and we find blown boards, bad components, all kinds of stuff that makes you wonder how someone could say on the internet that the item is brand new, but when we get inside of it to look, it's in horrible shape. So wish us luck on this one. Well, now that don't look too bad so far. She looks to be in good shape. Here's what's inside. There's a lot of wires there, aren't there? If you pull up this control board right here, there's even more wires down there. Now there's a power supply unit in the bottom of this drive. It's in this area right here. Let me go get a power supply unit and I'll show you what it looks like. Here's the power supply out of a blown up bus power supply. And this makes the plus and minus 18, the 24 for the fans. And it is very complicated. There's two switch mode power supply ICs. I don't know if you can see them, but there's one right here and then there's one over here. And what usually happens with these power supplies, I don't want to say usually, probably 50% of the time, this power supply unit fails and it just needs to be recapped. And you'll replace this cap, this capacitor right here, and this capacitor right here. And that will bring this power supply unit back up. But then other times, these things are impossible to fix. You can see they got a rock hard epoxy covering everything important. So it's very hard to work on this power supply unit right here. Next to impossible. That's why the only thing you can do is replace the 3 capacitors and cross your fingers. And underneath the power supply unit that we just looked at, there's a contactor. And either the contacts will weld themselves together, at which point you basically need a new one, or the auxiliary contacts will fail. They'll have high contact resistance. So you'll have high contact resistance that isn't good either. Well, everything looks good. No blown open ports. Let's power this thing up. I'll show you how to test them. It's not hard to hook these things up at all. Let's hook up the bus power supply. I have a power choke right here, and we're going to connect that to one L plus and 2 L plus. Now, we'll connect the 380 volts AC 3-phase to one U1, one V1, and one W1. Next, we're going to jump X1 pins 2 to pins 3 with this little jumper wire right here. There's pin 2 and here's pin 3. That will turn on the BB1 LED. Now, we're going to connect ZKS to ZKS, AUS to AUS, and EIN to EIN with a switch. We'll switch the EIN, but ZKS and OS will be jumped. That's what this setup right here does. Now we'll go plug in our power transformer that's creating the 380 volts AC 3-phase. We'll go plug that into the wall. Let's power up. Hold on to your horses. There we go. We have our plus 24 slash plus or minus 15 volt LED is on. Our BB1 LED is on. Mains is on. And power is on. Now we're going to measure our DC buses. It should be somewhere around 320 thereabouts. Let me go get my meter. Find a good place to put this where y'all can see that. I'll turn the light on. Okay. Now this connector is X9. This is L minus, that's bus ground. Here's L plus, that's bus plus. And we have 319 volts DC. That is good, good. Next thing we'll do is we'll come down here to the X3 connector. And we're going to measure plus 24 right here. There we go, we have 24.6 volts DC. Now we'll measure the plus and minus 15. That's plus 15.01 and minus 15.01. This is looking really good. Okay, we're going to measure in ohms whether these relay contacts are closed. We have the BB1 contacts, the UD contacts, the BVW contacts, and the TVW contacts. All of these should be closed when everybody is powered up and good. Hit on it. There we go. There's our BB1 contacts. That is good. That's closed. We have 0.2 ohms. The 0.2 ohms is my meter leads. Here's the UD contacts. Again, 0.2 ohms. Here's the BVW contacts. 0.3 ohms. 0.2 ohms. Here's the TVW contacts. Again, 0.2 ohms. Those relays are all energized and the contacts are closed with 0 ohms of contact resistance. Now, this X5 connector is where the auxiliary contacts sitting on top of the main contactor are brought out. It will tell you whether the contact is energized or not. So here's the normally open contacts. They should be closed now because we have our power LEDs on, indicating that the main contactor is closed. On the X5 connector, we have two terminals for K1 normally open and K1 normally closed. Now these two terminals right here connect to the auxiliary contactor that's on top of the main contactor, and they indicate as an output whether the main contactor is de-energized or energized. And the contacts of that auxiliary contactor, they go bad. And when they do, you have to go down to the bottom of the drive where that main contactor and auxiliary contactor is located, remove it from the drive, take that auxiliary contactor apart, and clean the contacts, put it all back together, and then you have good continuity here on this connector. On this bus power supply, these contacts are good. So we won't have to go down there and into the belly of the beast and clean those contacts. But I've done it before, and I have videos on how to take that auxiliary contactor apart. I put that up on the internet there, so you can watch that video. Now, part of that auxiliary contact is a normally open contact who, when closed, goes back up to the control board and tells the control board that the main contactor is energized. So when these contacts right here have gone bad with high contact resistance, it's probably a good idea to go down there and clean that auxiliary contact assembly.